Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is an ASRock Z790. Very nice board. I mean, decent. It's got PS2, so you can tell that this is for gaming purposes. Wi-Fi, DDR5, all that kind of stuff, and 1700 socket, which needs a replacement. To properly replace a socket, you need to mitigate the warping of the board. This one belongs to semi-flimsy ones. It's not very thick, but it is nice and sturdy. If after the procedure you just kind of put pressure on it and it behaves like kind of like a piece of paper, you messed up. You overheated it. It's ruined. It happens. Not to me, but it happens. Every day I tell myself that this is the day I'm releasing Rework Pro 118, and every day I find something that delays the release by another day. So today, hopefully, is the last day of testing. So we're gonna replace the socket on this board. This is not a customer board. So if you're waiting for the replacement, yes, I did receive your board, and I will replace the socket as soon as I finalize the release of Rework Pro 118. The final piece to the puzzle that I've been working on is to tune the PID loop. Rework Pro 118 has a button called Tune. If you hit that button, you set whatever temperature you want to tune it to. And without getting too much into the details, essentially it's a most primitive way of tuning PID loop. We heat up until we cross the set point, then we check how much did we overshoot, then we wait till it drops, then heat up to go across again, and after a few times, based on those oscillations, we just calculate values for proportional, integral, and derivative. Simple as that. That part is open source. If you go to my GitHub repository, Rework TC, you can see how it actually works behind the scenes. There's not much magic over there. It's really simple. You can upload it to any microcontroller starting from Arduino Nano through Uno, ESP32, 18 mega, quite a few, Raspberry Pi, obviously the Pico. Everything that works with Arduino framework will work with Rework TC. Then you just connect it to the computer and that's it. Now you have two options. You can tune the PID loop yourself, just providing proportional, integral, and derivative, or you can use autotune. So today we're going to use autotune on this board and we're going to replace the socket. I will likely make a fully dedicated video to tuning PID and how PID loops actually work, because it's important to understand that if you tune it at the temperature of, say, 75 degrees, the values calculated will be vastly different than when you tune it at, say, 150 degrees. And that's 150 degrees is what I would recommend tuning it at. Maybe 160, 165. Don't go too high. The problem with the previous iteration of my PID controller was that the heater would never really go to 100% of power, which is good because that means we're heating it very slowly and that's what we want. But on the other hand, when you really need the bottom temperature to grow to, say, 205, it's just lagging at 175, maybe 180, and that is not good. Now it did work in our last test, but the maximum temperature was at around 175 or something like that, 180. And then since the thermocouple is pretty much was pretty much underneath the socket, so as soon as the top heater started heating, that's when the bottom temperature raised to the level we wanted it to raise to. So for that reason, I spent the last few days tuning the software, both for the microcontroller and obviously Rework Pro, to achieve the best result. So the profile is pretty much the same, although I extended few steps. because it was lagging behind, but now it probably won't even be needed. The goal is that we never raise or we never start growing by more than 10 degrees at the time. And even I might, since the PID loop is tuned now, I might actually change the profile to grow by 5 degrees at the time. That's probably even going to be better. The whole idea is that our heater is slightly smaller than the board, so we need to heat it up very slowly for the entire board to heat up, because it will. If you give it enough time, it will heat up even though the heater is smaller. Now, would it be better if the heater was of the size of the board or larger? Most likely, but on the other hand, you don't necessarily want to heat up all of this side of the board to the temperatures that you want to heat up this side. But the difference between the temperature over here and temperature over here cannot be too large, because that will cause warping. But the main problem is that when we hold it by this hole, this hole, this hole, and this hole, or perhaps this one, we want this entire area where we hold it to be stable, even stable temperature, right? So if this side is colder, it's even better, because it doesn't really mean anything. It doesn't impact anything. But if we have high difference between this area over here and say this area over here, the board is going to start sagging down. It's going to create a little depression over here, a funnel in a way, and then the socket is just not going to solder on correctly, or it's very unlikely that it will be a successful replacement if the board deforms too much. So today we're going to try tuning it to this particular board. This is probably not something that you should do for each job separately, but you have such option if you're working on the boards that are vastly different. So this one is the desktop motherboard. They're all essentially the same. They don't differ by that much. But if you're now switching to PlayStation or some gaming board, some motherboard from gaming system, they are usually a lot thicker and they dissipate power a lot quicker. Which means the PID loop will have to be adjusted for that, because you want quicker reaction, because the board is cooling too quickly. All right, let's get everything set up and let's run some tuning and replace the socket. Okay, so first, we don't want the thermocouple at the bottom to be directly under the socket. So move it to the side as much as you can, not too far, but as much as you can. Yeah, somewhere over here. So it'll be sitting somewhere around this region over here. You don't want it too close to any of the holes, because that's going to impact the cooling and the heater is going to be overcompensating. Now let's hold it by this hole over here and this one over here, like this, and this one here, and this one here, and there. Actually, let's not hold it by the core. Change my mind. So what I want is just for the board to be super flat, because last time I had an issue and that was most likely a result of the board just not being leveled. Now position it so the heater covers the entire socket, obviously. There. Now let's check the bottom thermocouple. Where is it touching? It is too close to the hole. So what I do, I grab a big ass tweezers and just move it where I believe it'll be better. There. So it's in between over here. It's still a little maybe too close to the holes, but it should be fine. Now don't forget to tighten these, because I usually forget and that can cause issues. Then the top thermocouple. Okay, we have perfectly a lot of room over here to place the thermocouple. Now when you start version 1.18, it'll ask you whether you want to enable Rework TC controller. So if you have it, hit yes. The first run might take a little It might take a little while because, well, depending on how many COM ports you have connected to the computer, because Rework will go from COM port to COM port searching for Rework TC. But once you find it, it is stored, so then that port is going to be used, unless you change the device and that port no longer exists or whatever, then it'll start searching again. Now, I recommend using ESP32 because that will work on 11K baud rate. If you use Arduino Nano, it's going to be 9600. It's not a huge difference perhaps, but it just works better on ESP32. Plus, if you use Heltec, you have a display, you have Bluetooth and all that kind of stuff. I would recommend ESP32, but it's a difference of say $10, $15 maybe actually maybe even $20. I think they go for like $30 nowadays, while Arduino Nano you can just get for $8, maybe 10. Once detected and configured, you will note that there is no longer a preheat and long preheat buttons because they're no longer needed. You control the bed through the profile. You also see that our PID configuration right now is this. So we have 353 for proportional. Integral will always be the lowest out of all those three, as opposed to what you see on the PC410. And derivative, well, you have a tiny explanation over here. Just essentially, if you want to play around with the numbers, you have a little explanation. What does each kind of impact? But it's not as simple as it is explained over here. It's just to give you a general idea what they are responsible for. But they work together. So you would think that the best option is to just change one at a time and see what it impacts. But that's usually not the way to go. Tuning PID loops it could be a little tricky, it could be a little difficult, it could be a little complex. So definitely when you want to play around with this, just read at least what the PID loop does, or go into the code. If you're a coder, go into the code, see how our PID loop is implemented. So instead of guessing or trying stuff, let's do this. We're gonna hit tune. Well, we're gonna hit tune if we connect to the controller. Now you can set PID without connecting to the PC410 controller over here, sure, because it's not needed. But to run autotune, you need to be connected to PC410 because PC410 cuts the power from Rework TC. So once connected, let's hit autotune. And what we want here is to just pick a temperature at which we will be working. So 150 is a good middle of the road temperature. I would say 175. I'm gonna try on 175. I wouldn't go higher than 180, but again, it depends on what you're working on. If you go too high, the board is gonna be resisting a lot. So the PID autotune is gonna try to compensate. So it's gonna be a lot more aggressive. If you tune it at too low temperature, the lowest temperature you can tune at is 50 degrees. If you tune at 50 degrees, the numbers are gonna be very different because it's gonna be growing quickly to 50 and it's gonna be staying at 50 because it's a relatively low temperature. That's not what you want. You want a little higher temperature because you want the PID to see that it needs to generate, it needs to output some power just to keep it at the temperature. So if you do it on 50, it'll just heat up to 50 and it'll turn off the heater, right, immediately. Because the board is going to be staying at that temperature. At 175, on the other hand, it's going to be cooling very quickly. So just to hold the 175 temperature. Perhaps we need to be outputting 15-20% of power to the heater just to hold the temperature. So essentially it almost never goes to 0% of power to keep to hold the temperature. If it drops to 0% power, we're gonna have oscillations. Now if it's 5-degree difference, if it's oscillating by up to 5 degrees, within 5 degrees, that's fine. You don't have to worry about that. But if it overshoots by 15 degrees or 20 degrees even, I've seen that, that's not good. That's a bit too much. It shouldn't overshoot by more than, usually around 3, maybe 4. But I keep it, if it's within 5 degrees, so we set it to 175 and it grows to 180 at times, that is acceptable. But we obviously prefer it not to overshoot too much. The important thing is that we want it to grow slowly for the board to heat up slowly. And I actually just realized something. You know what? I don't want to tune it on this board because, yeah, this isn't a customer board, sure, but it's just going to put unnecessary strain on this board. So let's just tune it on a similar board that is for parts, like so. There's no socket on it. Okay, the thermocouple is in the same place, right? We don't really need a top heater for this, but let's just keep it. And let's tune it at 175. Now, as you turn on the autotune, the heater will go to roughly 70-75% of power. And if it struggles to reach set point, that power will be growing until we overshoot. Then once we overshoot, it's going to start turning on and off. It's going to start cycling between full power and no power. And you can see the orange dot over here. That indicates that the autotune is running. So you just essentially run it until it disappears. The maximum time is 10 minutes, but it's not going to take 10 minutes. And it's going to turn off completely. So the red dot over here indicates that the Rework TC is enabled and it's working. And the orange dot indicates that it's in the autotune state. So as we can see, the PID numbers at the moment, right, about 3.5, 0.2 and 12.5. And these are going to change because these are, I think these were tuned to 150 degrees. After roughly 60 seconds, if I remember correctly, the power went up because we didn't reach the set point. So in this case, since we're heating up from, what was it, like 25, 30 degrees, all the way to 175, the power will grow all the way to 100%. That's why I didn't want to use the actual board we're gonna work on, because we're gonna just heat it up a bit too much. So this is very fast ramp. This is the fastest as it goes, because that's how the autotune is implemented. If you have better idea of implementing an autotune, feel free to open a pull request and propose your idea. Let's test it. This, as I said, this is a very primitive way of auto-tuning, but it works. Also, remember that we're working with a relatively unique configuration over here. The PID loops used for like hot air over here is going to work way different than this one. We have a large delay, so once we turn on the heater takes a while to start heating. Then we have a distance to the board, then the board needs to heat up. So there is quite a delay. That's why we're working on a 2-second cycle or 2-second period, which probably will be increased to 3 seconds. For that reason, if the PID loop just increases the power very quickly and then drops it very quickly, and basically it reacts very quickly to changes, that's not good. That's not good because the heater is just not capable of reacting that quickly or changing its output that quickly. So we want those reactions relatively slow. Okay, as we approach 160, you can see how our delta is starting to increase, the difference between the bottom and the top of the board. It was going pretty much the same all the way to like 145, 150. It was pretty much holding at the same level, which tells you that the board is relatively thin. That's why we want to tune at higher temperature, because now the heater is going to have to fight against the force of nature that cools down the board. However, you can see the problem over here. Our step is almost complete. It's set to 10 minutes. 10 minutes is not enough to heat up to this temperature. So for now, what I'm going to do, I'm just going to stop it. And I'm going to tune again, giving it another 10 minutes. I will fix that, but for now we just need to work around it. It's just set to 10 minutes, right? If the auto tune doesn't complete in 10 minutes, it's never going to complete because the heater is just going to turn off. Now we're going to start seeing some fluctuations because 175 is a little more difficult to keep steady as opposed to, say, 120 degrees. Now we can see how the heater starts oscillating. So we want to overshoot and we want to wait for it to drop down, then turn on again, and so on until we calculate the values. So as soon as we actually hit the temperature that we want, the tuning doesn't take that long. And the tuning is done, and our final numbers for this setup is 250, 0.13 and 938. So this is tuned to our environment essentially. Remember that when you run autotune and you have a draft or it's pretty cold in your shop, your numbers are going to be different. The controller will essentially try to compensate for those losses. I always say that you want minimum, especially when you auto-tune, you want to stop all the ventilation and you want to keep a stable temperature in the shop. Now then, when you actually work, you know, I start the ventilation when I start wicking and stuff, obviously. But for the process of preheating and stuff like that, the best advice I can give you is to just use Rework TC, get the long 40-45 minute preheating profile, and just leave the shop. Technically, it's not super safe to leave the machine running without any supervision, but it's kind of depends on what you value more, your health or you know, fire hazard in your shop. Alrighty, so supposedly we are tuned now, so let's remove the hot board from over here. Let's wait for the heater to cool down a little bit, because if I put the board on it right now, there's a lot of residual heat coming from the heater, so we don't want that. So let's allow the heater to drop to pretty low temperatures, like maybe 50 or something. Right now it's at 180, well, 200, 213. So it's a bit too high, 225. And so now it'll start dropping. So let's leave it for a few minutes, cool down, and then let's place the board and start the actual profile on our new PID settings. Alrighty, we are done. So, what was the issue? Well, number one, unfortunately, yeah, Rework Pro, I need to improve the timing of the PID tuning, because yeah, if you go from room temperature to 175, that 10 minutes that is designed to allow the PID loop to auto tune is not enough. So I had to stop and start again. So I need to fix that before the release. So again, it's not going to be released today. The second thing that I noticed, when I set the bottom temperature to, what was it, like 220, the temperature at the bottom was so high that the top heater didn't want to go up in power, which means I couldn't remove the socket. It was just hovering at the temperature of loosing, but not enough. So I had to do what, like 2 cycles, and I had to increase the temperature to 220 from 215. Now 215 is perfectly fine for removal, but when the bottom temperature is say 175, 180, so now the bottom temperature goes a little bit more aggressively, although we did see some lagging behind here and there. So it's not super aggressive, but it could even be a little more aggressive. But that's what we want. We want slow, non-aggressive heating to mitigate the warping, of course. Now the board, well, the board overall is a little bit deformed, but the back is perfectly flat. It looks good. You see by the reflection of the lamp, right? There's no deformation right now, and the socket looks to be sitting. The alignment is okay. I don't know what temperature did it drop, but I increased the temperature to 220. Hopefully 180, 180 seconds was enough. It's sitting very well, yeah. Now is the board flimsy? It is not. Okay, so no overheating. We didn't overheat it. So it should be good. So essentially it's almost there. It did warp a little bit, but not around here. It warped a little bit, show it to you like this. So this side just went up a little, right? But this remained flat as far as I could see. Judging by how flux was floating or flowing, I didn't notice a huge deformation. So I think this is good. So I think this version of Rework TC is gonna be a production one. All the code and everything is already pushed, so you can upload it to whatever device you want it to be uploaded to, and obviously you can control it with just terminal. You don't necessarily need Rework Pro for that per se, but you can already like install it, and I'm hoping Rework Pro version 1.18 will be released tomorrow. The day after tomorrow should be the latest, because I'm really close now. I'm just figuring out some minor details that would not necessarily impact how it works. All the bugs looks like have been resolved. Now it's just optimizing for easier use. And that's it. I think we are ready to start working on customer boards after this one. I just need to clean it, put it back together, and return it. Alrighty, thank you guys very much for watching. I do appreciate you, and I shall see you guys in the next one.